Today I will discuss about the topic computer network error control lecture 1. So yes, error detection and error correction. That topic to be covered in this lecture. So discuss one by one. Then what do you mean by error? Error କଣ? ଯେତେବେଳେ ସେଣ୍ଡର୍ସ ଡାଟାଟା ସେଣ୍ଡ କରୁଛି ରିସିଭର ରିସିଭ କରିବ ତ ଯେତେବେଳେ ଡାଟା ଇଫ୍ ଡାଟା ଇଜ ରିସିଭ ଯୋଉ ଡାଟାଟା ରିସିଭର ପାଇଛି ଯଦି ସେଟା ଯାହା ସେଣ୍ଡର ସେଣ୍ଡ କରି ତା ସହିତ ଯଦି ସେମ୍ ନହେଲା ଦିସ୍ ଇଜ ଏରର ଇଫ୍ ଡାଟା ରିସିଭ୍ ଇଜ ନଟ୍ ସେମ୍ ଆଜ୍ ଦ ଡାଟା ସେଣ୍ଡ ଦେନ୍ ଦ୍ୟାଟ୍ ଦିସ୍ ମିନ୍ସ ଏରର ହାଜ୍ ଅକର୍ ଧର ଯଦି ସେଣ୍ଡର ଯୋଉ ଡାଟାଟା ପଠେଇଛି ରିସିଭର ଯଦି ସେଇ ଡାଟାଟା ଯଦି ପାଇନି ତାହେଲେ ଏରର ହେଇଛି ବୋଲି ଆମେ ବୁଝିବାକୁ ପଡିବ so there are two types of error that is single bit error and that is another is burst error. So single bit error. Single bit error कौन ना only one bit of given data unit is changed from 1 to 0 or 0 to 1 से କହିଛି କି ଯେତିକି ବି ଆମର ଡାଟା ଆମେ ସେଣ୍ଡ କରୁଛେ ତ ସେଥିରେ କେବଳ ଗୋଟେ ବିଟ୍ ଚେଞ୍ଜ ହେଇଥିବ କଣ ଚେଞ୍ଜ ହେଇଯିବ ଗୋଟେ ଡାଟା ୟୁନିଟ୍ ଚେଞ୍ଜେସ୍ ହେଇଥିବ ସପୋଜ सेंटर सेंड 0 0 0 0 0 0 1 0 एक fifth bit is 0 to 1 is change so this is the corrupted bit so obviously this 0 is changed to 1 so so this 0 is changed to 1 so that's why this is single bit error only a given data unit is changed from one bit 1 to 0 or it may be 0 to 1 so then there are two types of error one is burst one is single bit error then burst error burst means two or more bits in the data unit has changed from 1 to 0 or from 0 to 1 burst error means ଦୁଇ କିମ୍ବା ତାଠାରୁ ଅଧିକ ବିଟ୍ minimum is 2 maximum is anything so this is called burst error ଦୁଇରୁ ଅଧିକ ଯଦି ବିଟ୍ସ ମାନେ given data unit ରେ ଯଦି କିଛି ଚେଞ୍ଜେସ୍ ହେଲା କିମ୍ବା ସେ କେମିତି ଚେଞ୍ଜେସ୍ ହୁଏ 1 to 0 or 0 to 1 that is called burst error in the burst error case one term is introduced that is burst length. Suppose sender is sent 01001010 and the receiver receive the data that is 01101110 but there is 2 bit data is changed from 0 to 1 another is also 0 to 1 so from the beginning of the bit change to next bit change that is the burst length that is 0 1 2 3 4 that is 4 unit so burst length is 4 note number of corrupted bits or affected bits depends on the data rate and duration of noise there is no tension data rate and duration of noise ଆମର କରପ୍ଟେଡ ବିଟ୍ଟା ଡିପେଣ୍ଡ କରୁଛି କି ଡାଟା ରେଟ୍ ଉପରେ ଆଉ ନଏଜ୍ ଡ୍ୟୁରେସନ୍ ଉପରେ ଡିପେଣ୍ଡ କରେ ଯେତେ ଡ୍ୟୁରେସନ୍ ଅଫ୍ ନଏଜ୍ ଆଉ ଡାଟା ରେଟ୍ଟା ବଢ଼ିବ ସେତେ କ'ଣ ହବ corrupted bits increase କରିବ burst error is more likely to occur than a single bit error କାହିଁକି ନା single bit error ଟା ବହୁତ ରେୟାର ଘଟିବ କିନ୍ତୁ burst error ବହୁତ ହାଇଲି ଘଟିବ କାହିଁକି ନା number of corrupted bits or affected bits କେମିତି ବାହାରିବ because we study note that depends on the data rate and duration of noise. So data rate into noise duration that is equal to the number of corrupted bits or affected bits obviously. So for example, for example, data rate is 1 kilobytes per second that is 10 to the power 3 bits per second. So noise and given these two are the given data of any question. Noise duration 1 by 10 second. So number of corrupted bits or affected bits is equal to 10 to the power 3 bits per second into 1 by 10. That is 1 by 10. So 10 10 कटिगला और रहला केते 100 तो 100 bits obviously 100 bits second second भी कटिगला तो number of corrupted bits how many bits 100 bits. And another example, data rate 1 megabytes per second. Kilobytes means 10 to the power 3, megabytes means 10 to the power 6 bits. You know, so noise is 1 by 10, so number of corrected bits or affected bits 10 to the power 6 bits per second into 1 by 10 second, so equal to 10 to the power 5 bits, that is 1 2 3 4 5 1 lakh. बुला रहे थे तीनटार क्लास है कुड़ी एडी अछि आंधे जमाने के तुलजो टेंशन नहीं तुम तो जतरा जीव जीव नल रहि जीव एटा error control is of two types. One is error detection, error correction. So suppose you're Raju, this is Rani. This is Hyder, this is Delhi. 5,000 is corrupted because here Hyderabad Raju is sent 5,000 to Rani in Delhi, that is 4,500 is received Rani. So corrupted is 5,000. So you can understand this concept. So how do you mean by redundancy in error control? The central concept in detecting or correcting error is redundancy. To be able to detect or correct the errors, we need to send some extra bits with our data. Redundant bits are added by the sender and removed by the receiver. एरर को डिटेक्ट करबा किंबा करेक्ट करबा पे हमें किछि एक्स्ट्रा बिट डाटा सहित हमें सेंड करा दरकार सो से एक्स्ट्रा डाटा को हम कहबा redundant bits are added by the sender and removed by the receiver. So error control is of two types, error detection and error correction. So first is data plus data. Send and receive. Send. This is data plus data. This is the first step, but practically it's not used. So error detection. Error detection is nothing but we are only looking to see if any error has occurred. The answer is simple yes or no. We are not even interested in the number of corrected bits. A single bit error is same for us as a burst error. Error detection कौन कहूची कि माने से कौन कहूची जहाँ भी एरर घटी जी ताको कौन कहूची yes no ରେ ଦେଇଦବ କିନ୍ତୁ ସେ କହିପାରିବନି କି କେତେ ବିଟ୍ସ କରପ୍ଟେଡ ହେଇଛି। ଗୋଟେ ଏରର ଡିଟେକ୍ସନ ସ୍କିମ୍ ପାଇଁ ଏ ସିଙ୍ଗଲ ବିଟ୍ ଏରର ଇଜ ସେମ୍ ଆଜ ଦ ବ୍ରଷ୍ଟ ଏରର। So error correction. In error correction, we need to know the extra number of bits that are corrupted, and more importantly, their location in the message. Error correction means कौन? Extra number of bits जोटा कि corrupted है, ଆଉ most important होची कौन? ना message को message रो location corrupted है सेटा जानले देखि हम error correction कर परिया। So error detection and error correction note 500 टंकिया। Correction of error is more difficult than detection. Detection is easy than correction because the correction of error is fast to define the location of message.
9 point
कौन
CG
8.08. If we need to correct a single error in an 8 bit unit, we need to consider 8 possible error locations. If we need to correct a single bit error in 8 bit data unit, 8 bit data रे धरा जते हम गोटे सिंगल एरर को हम करेक्ट करबा, we need to consider 8 possible error location. 8C1. Suppose these are the 8 bits. We need to correct a single error. So 8C1. That is 8 possible combination error location. If we need to correct 2 bit, if we need to correct 2 bit error in 8 bit data unit, we need to consider 28 possibility. कैसे? Suppose data is 10101010. 8C2 8 8 factorial divided by 2 factorial minus 8 minus 2, that is 6 factorial. 6 factorial 6 is cancelled. Then 8 into 7 divided by 2 to the 4 8, that is 4 into 7, that is 28 possibilities. So in this way, so error control is of two types already we discussed, that is error detection and second one is error correction. So errors detection is of five types: simple parity, 2D parity, checksum, and CRC. Also, we can data plus data. Also, error correction scheme, that is Hamming code. Once notice error, simply discard. Whenever error is noticed, discard the error. Ask for retransmission, and the receiver is sends to sender for sends again data. So error correction is capability of correcting error does not require retransmission. There is no retransmission of data. Hamming code can correct single bit error. Hamming code is correct single bit error. So logic for error detection.
ତାପରେ ଛାଡିକିଟାରେ ଭଏସ ରହୁଥିବେ ନାଇଁ ପାଗଳ ହେଇଗଲି ବୋଧେ
Logic for error detection. Error detection is based on block coding. What is the logic behind error detection scheme? So error detection is based on block coding. What do you mean by block coding? In block coding, we divide our message into blocks, each of size k bits, called data bars. Each of size k bits, that is called data bars. We add r that is redundant bits or extra bits to each data word, and the resulting word is called the code words of length n, that is n equal to k bits, that is data words plus redundant bits, that is n, that is code word equal to data word plus redundant bits. In place of sending data words, we send corresponding code word. ଆମେ ଡାଟା ୱାର୍ଡ ସେଣ୍ଡ କରିବା ବଦଳରେ ଆମେ କୋଡ୍ ୱାର୍ଡକୁ ସେଣ୍ଡ କରୁଛେ by the sender side. So here is the example. Suppose this is the message 00011011. So suppose 00011011. This is the suppose this is the data. Then here the message is divided into size of blocks. So so the message is divided into blocks, the size of k bits, that is k equal to your 2, that is 1 and 1, that is 2. So the size of each block is k bits, that is k equal to 2. So this is called the data word, this is called data word, this is called data word, this is called data words. Let k is equal to 2 and r equal to 1 bit. So data word is of 2 bits and code word is of 3 bits. So here k equal to 2, and suppose the redundant bits are extra bits 1 bit, so data word is of 2 bits and code word is of 3 bits. How? Because the code word is referent, that is n, the data word is k plus the redundant bits, that is 2 plus 1, that is 3. Okay, so here is the data word, that is 00, then 01, then 10, then 11. So we add the redundant bits in, suppose, in right side. So the green color is your the redundant bits. Suppose the data word is 00, then the redundant bit is 0. Redundant bits you can choose as your choice. There is no rules for redundant bits. So the 01, again 1 is the redundant bits, 10 and 1 is the redundant bits, 11 is the 0 is the redundant bits. So this is the data word, that is k bits. So combination is how 2 to the power k. That means k bit, that is 2 combinations. Code word is n bits, the 2 to the n combination. 2 to the power n combinations minus 2 to the power k code word are not used. These are called the invalid code word. 2 to the power n minus 2 to the power k code word that are not used, that is invalid code word. Always n is greater than k, because n is the combination of k plus r. That's why n is bigger than k. Okay, so don't worry about the invalid code code word. So we will discuss what are the invalid code words and what are the valid code words. So you see the previous example. Here is the data word. The message is divided into blocks. Number of block. Each block is called as data word, and here the data word is represented as k bits. K is nothing but that is 2 bits. K is equal to 2. So here is the code word. That code word is your by adding the data word plus return bits, that is code word is the valid code word. Then find what are the invalid code words. Suppose the code word is a n, that is 3 bits. So there are 2 to the power 3 bits, 2 to the power n combinations. That means 2 to the power 3, that is 8 combinations of code word. So 000 001 up to 111, that is 0 to 8, 0 to 7. So check this code word, check with this code word. If match, then correct, otherwise invalid code word. So 000 again is 000 is possible. So this is the valid code word. Then 011 011 011 011, yes, this is the valid code word. Then 101 101 101, this is the valid code word. 110 110 110, this is the valid code word. 001, so 001 001 is not, this is the invalid code word. 010 is not present, so this is the invalid code word. 100 is not present, so this is the invalid code word. 101 is present, so this is the valid code word. 110 is the valid code word. 111 is not present, so this is the invalid code word. So these are the 4 invalid code word. How we can find, I will discuss, already discuss. So invalid code words are how, what are the number of invalid code words? That is the formula, that is 2 to the power n minus 2 to the power k. Invalid code word, that is the invalid code word. 2 to the power n, that is n is the 3 and k is your 2. So 2 to the power 3 minus 2 to the power 2, that is 4. Invalid code word. So code word is of two types. One is your valid code word and another is your invalid code word. Valid code word is your 2 to the power k. Invalid code word is your 2 to the power a minus 2 to the power k. You understand how it will define. Next, with k bits, we can create a combination of 2 to the power k data words. With n bits, we can create a combination 2 to the power n called code words, already discussed. We know that n is obviously n is greater than k, that there exists one to one correspondence between code word and data word. Hence 2 to the power n minus 2 to the power k are invalid code word. Hence 2 to the power k are valid code words. These are the formula we will already discussed. Then error detection using block code. So if the following two conditions are met, the receiver can detect a change in the original code word. If error detection, how the error detection is done by using block code. There are two conditions. If satisfied, then the receiver can detect a change in the original code word. If first condition, the receiver has a list of original code word. The receiver has a list of original code word. The original code word has changed to individual one. The receiver has a list of original code word. First point, if receiver पाखरे जो original code word generate sender କରିଥିଲା ତ ତାର list ଥିବ then the original code word has changed to invalid one. সেটা ବି ଥିବ ତ ଦୁଇଟାକୁ ସେ ଚେକ୍ କରିବ these are the data words and these are the valid code words. This is the first step. Then each code word is sent to the receiver may changes during transmission. Each code word sent to the receiver may change during transmission. If the receiver code word is same as the one of the valid code word, the word is accepted. যদি রিসিভ কোড ওয়ার্ড ইজ সেম আর তো valid code word যদি valid code word সହିତ ଯୋଉ code word ଟା ସେ receive କରି ଯଦି ମ୍ୟାଚ୍ କରି ଗଲା then this word is accepted. Suppose you can see, suppose the sender sent 000, no error, 000 is received. This is the code word, this is the code word is compared to the original code word. So original code word and the received code word is matched. So this is a valid code word. That means this is accepted. The receiver received code word is not valid. It is discarded. Suppose the received code word is not present in the original code word that present list in the receiver. So it match with the this code word. If they're not matched, this is the invalid code word. So this is rejected by the receiver. Receiver can detect the one bit error. The code word is corrupted during transmission, but the received word is still match a valid code word. The error remains undetected. Receiver fails to detect the error. This is the valid code word, but this is accepted, but it is not to fail to detect the error. Obviously, because the sender is sent 000, but the 2-bit error 110, but this is a valid code word present in the list of the receiver. So obviously, this is the valid code word. So accepted receiver, but the receiver does not know what code word is sent by the sender. That code word is your 000, but you receive 110 code word. This is also accepted. So fail to detect the error. Thank you.